Hello, my name is Aiden Hrinson, and this is my lab report for Lab 3 bar magnets. So, the purpose of this experiment was to determine the magnetic field of a bar magnet both on and off axis. We then take those experimental values and translate them into GlowScript to find simulated values. Then we compare those two and see how much of a difference we get. So, some findings we had were that the magnitude of the net magnetic field increases as the distance between the bar magnet and the magnetometer decreases. We also found that the magnetic dipole moment for the bar magnet was 11.111. The measured off-axis magnitude for the magnetic force was 3.416 times 10 to the negative 6, and the simulated off-axis magnitude was 5.938 times 10 to the negative 5. So some fundamental constants that we used was mainly the fact that the magnitude of a magnetic dipole on axis is relatively equal to mu naught over 4 pi times 2 mu over r cubed. And this is for when it is on axis and when r is much, much greater than s. So for the setup for this experiment, we first did the on-axis portion, which is depicted on the left, where we moved the magnetometer along a meter stick and recorded the components for the magnetic force at different locations. Then, for the off-axis portion, we went to a designated location of 20 centimeters, then went off-axis 20 centimeters, and recorded the component values there. So, when that is all broken up, we get the for the top half, this is all of the data for on axis, with the graph being generated from those average points. And then in the bottom, we have all of the off axis data. And so some of the important values from this was that the perpendicular distance that we measured from was 0.2187 meters. The slope of our graph was negative 2.4916. The y-intercept was negative 13.017, and that the net magnitude was 3.416 times 10 to the negative 6 for the off-axis. So, some of our observations were that when the magnetometer is far away from the magnet, we register a near zero field, and that as the magnetometer moves closer to the magnet, the measured field increases. We also found that the dipole moment, or mu, was 11.111. So now we have the GlowScript, where the beginning part was determining the magnetic force due to the dipole and where to place the magnet. Then we have down below the locations for all the different vectors, for all the on-axis vectors. Then computations for the size, location, and color of all of these vectors. For the on-axis parallel, they would be orange, and the on-axis perpendicular, they will be cyan. Then the calculation for the size and position of the off-axis vector, which is in magenta. So this white is the magnet, and the vectors are all of the different on or off axes. So here are the computed values for that, or simulated values for that. So when comparing our simulated and experimental values, we found that we had a 94.25% difference, which is fairly high. So some possible sources of error were that we weren't lined up exactly with magnetic north, and then we would have had to factor in some of Earth's magnetic field, and that our observed point could have not been exactly where we marked it, and so that way our measurements weren't exactly on. So the first question I alluded to earlier was that if we don't orient with magnetic north, then we'll have to factor in Earth's magnetic field into our calculations. So our end values will be the same, but there will have to be extra back-end computation to it. And if we lined up two identical magnets together and stuck them end to end, the magnetometer won't really know that it's two magnets. It'll just register it as one very strong magnet. But some of our math might not line up because then we're reaching into a territory where the observed distance away from the magnet isn't much greater than the length of the magnet itself. Thank you very much.